Through making caramels, how can you apply some of the cooking concepts into stoichiometry? You need to figure out which type of sugar will allow you to make enough caramels for your entire chemistry class. You need to develop and answer questions about caramelization in order to help yourself make caramels. Our project will teach students stoichiometry through the process of solving the various problems presented in our project. They must use and correctly execute several stoichiometry skills, as well as defining numerous concepts.
Okay, the objective. You love candy. There is plenty of table sugar in your mom's kitchen. You decide that you want to make enough caramel candies to give to your chemistry class. So you know that a very simplified reaction describing the conversion from table sugar to caramel is as follows. Okay, it's right here. Okay, so you need to complete the following statements, questions, I don't know. Okay, define a mole. A mole is a unit of measurement used in chemistry to express amounts of a chemical substance.
Okay, when you balance this chemical equation, when you put the 4 there, the 6 there, the 14 there, and the 3 there, you can see that all of the atoms add up so that they're equal on both sides.
Okay, to determine the molar mass of each reactant product, you take the number of atoms of each element and you multiply by the atomic weight to get the final molar mass. And so you have to add them all up for carbon, hydrogen, oxygen, and so on.
30 of these caramel candies weigh 266 grams. How much table sugar in grams do you need to produce enough candy for the class of 30? So you put 266 grams of caramel over 1, and then 1 mole of caramel is equal to 170 grams of caramel. And the ratio in the equation is 4 moles of table sugar to 6 moles of caramel. And 342 grams of table sugar to 1 mole of table sugar. And then when you multiply all of the ones on the top and divide by 170 and 6, the answer is 357 grams of table sugar.
Okay. After using the calculated amount of sugar in the problem above, you realize that you only made 200 grams of caramel. What is the actual percent yield? So, to solve this, you take the actual yield and divide by the theoretical yield. And that equals x over 100, so you can get a percent. And when you solve the problem, then you get 75.2. So the actual percent yield is 75.2%.
Okay, so you have a limited amount of materials in your mom's kitchen, and you can make caramels with different kinds of sugar. And so you have 300 grams of table sugar, 470 grams of brown sugar, 360 grams of corn syrup, and you still need to make 30 caramels, which is 266 grams. So you need to figure out which product to get, which product you can use to get the amount of caramels you need. So you balance all of the equations, which is just like on the other problem, and then you solve them all out to figure out how many grams of caramel you get with the amount of sugar you have. And so you get 268 grams of caramel from table sugar, 177 grams of caramel from brown sugar, and 350 grams of caramel from corn syrup. So you can use table sugar or corn syrup.
Okay, assuming that you have the 360 grams of corn syrup from above, what is the limiting reagent in the chemical equation with corn syrup, considering you only have 200 grams of oxygen? So to solve this, you take the 360 grams of corn syrup and you multiply by, or you divide by 180, and that's the molar mass of corn syrup. And then you multiply by the ratio of corn syrup to oxygen in the equation above, and then you multiply by the molar mass of oxygen. And so you end up getting 72 grams of oxygen because all of the units cancel each other out, and then you're left with grams of oxygen. And so if you only use 72 grams of your 200 grams of oxygen, then the limiting reagent is corn syrup because you used it all.
So, for H, determine the grams of excess reagent left at the end of the reaction above. You take the 200 grams of oxygen, and then you subtract the 72 grams, determine...
No, wait, no, 72.
Oh, right. 72 right there. And it ends up a simple subtraction problem to get 128 grams of oxygen. Okay, so how many moles of excess reagent do you end up with for equation F above? So you take the 128 up there and you divide by 100, or just 32, which is the molar mass of oxygen, to get 4 moles of oxygen. So easy, even I can do it. And then you come to the last problem. Solve for the amount of molecules of the excess reagent. And it gives you Avogadro's number. So you take the 4 moles of oxygen you found up there, and then you just multiply it by that Avogadro's number, and you end up getting that answer.
Woohoo!
Yay!